New lesson in the forces unit, and it's new, but it's kind of not, because net force is not new. We've done that lots and lots of times in grade 11 and already in our review, but we are doing net force in 2 dimensions, and all it's going to do is tie in the elements of vector addition that we did in the first unit. So that vector addition, we stick with it forever. Okay, so yeah, you can just copy this down, but basically we're going to look at every question from two strategies. Or I'm going to show you how to do at least a couple of them using both strategies. Here's our first example. I got the Ex1, what I've got here, just before you've got this part written down. So I'm going to show you how to solve it. So on the left side of the page using the sines and cosines method, the triangle method. And on the right side is the X and Y component method. And for the most part, you can pick which method you think is better. A little hint, if you're ever taking calculus, you'll be using sines and cosines. You do almost a lot of these same types of examples even. Maybe not a lot, but at least some. But you use this strategy here. Russell never does the X and Y components. He doesn't think it's general case enough. He would do it something like, not the X and Y, but the 43 degrees east of north and the 57 degrees north of west components or something like that. He thinks it's insulting to do anything as specific as vertical and horizontal. Anyway, that's math teachers. So you can choose a method. I'm going to show you both, okay? And this is going to take a while, so I'll do this example. I'll do them in different videos just so that you don't have these huge videos. But here we go. So sines and cosines, the strategy is draw a free body diagram. And unlike we've done in the past, we're not going to do facts and fe. We'll save that to the X and Y component method. You're actually just going to draw the vector as it says. So it's given as 14 newtons, 29 degrees above the horizontal. It also tells us the gravity force, which will be straight down. There'll be no other forces acting on the ball. We're assuming there's no air resistance. And so we're looking for net force. Okay? So what I do is I take these two and I'm going to add them. Okay? I'm going to add these two vectors, making a triangle out of them, and then find the resultant, and that'll be the net force. So it doesn't matter, the order is important. So I drew this one first. I drew 1.4 down. See, it starts here, goes down, then I add the 14 newtons on the angle up here. And my net force is the yellow. It's from where I started drawing to where I finished, right? It's a resultant force, just like when we did displacements or something like that. It's the same thing. If I'd drawn the 14 first, that would be fine. I'd draw the 14, then here would be the 1.4, and then my resultant would be from here to here, and it would be the exact same size and exact same angle as this yellow one. It just would have been shifted down. So it doesn't matter which one you do first, okay? So applying cosine law, a couple things about my triangle, I guess, is that this angle will be 61 degrees because these two have to add up to 90, right? So I got 61 degrees here. This is the angle I'm going to look for, okay? And so I apply the cosine law. I'm going to zip through because I know you know how to do cosine law. Ends up with 13 newtons, okay? Then I apply sine law to find out this angle. And if you remember grade 11 math very well, you might know that there's going to be something funky going on here. And in fact, you do get something funky, 67 degrees. Now, this is not 67 degrees. This is clearly bigger than 90 degrees. This is what we call, you might remember from grade 11 math, the ambiguous case. Okay? That's not, which isn't a big deal. You just have to remember what to do with something if you get the ambiguous case. The actual angle will be 180 minus 67. And you hopefully remember that in grade 11. So if you see something like that, that's what you can do. If that makes you feel insecure, do the X and Y method. Because it's more steps, but you wouldn't get something like that. Okay? Anyway, so you end up, we're going to say the angle is 113. So if I kind of redrew, that just blew up on the angle a bit. Here's our 113 degree angle. If this part's 90, I'm going to say my net force then is this little bit right here. It's 23 degrees, right? That would be 23 from here to here. So it's 23 degrees above horizontal. Okay? And that's the solution using cosine law. Several more steps, okay? But no worries about things like ambiguous case is the X and Y component method. The other reason, sometimes I use X and Y components, you theoretically can use sine law and cosine law if you have several forces, like more than 2 to add up, but it's different, okay? If you have a bunch of forces, I would use x and y components. This case is a nice case for sine law, this particular example, because there's only two forces. But more than that, and you're then trying to find the net, because it doesn't work out to a triangle anymore. You kind of have to do extra steps of sine law, and so I would just jump right into cosine method, or sorry, x and y method. Anyway, as you can see when I do my free body diagram, when dealing with x and y components, I do x and y components, right? I'm not doing angles anymore. So I just add up all the x, add up all the y, do Pythagorean theorem at the end. Okay, just like adding displacement vectors. So my net force will be the sum of all the force in the x direction plus the sum of the force in the y direction. Notice I chose a positive sign convention, so up and to the right. Start the process. So you can see a little table I drew here. So on the x side, so my net force in the x direction, it's only FAX, that's the only force in that direction, which will just be the 14 cos 29. Okay, here's the picture of it, right? So here's 14. So the x component down here, it's adjacent to the angle, so 14 cos 29, so I get my number. Y direction, I have two vectors in the y direction. I've got my 14 sine 29, my FAY, and I also have gravity. Gravity is going to be negative, right? It's negative because it's down, and I'm calling up positive. Okay, so that's my net force in the y direction. So here I'm looking for my overall net force. It's vector math, not number math, so you have to make a triangle, right? Make my right angle triangle, FAX, or sorry, a sum of FX and the sum of FY, and get the angle. Use Pythagorean theorem. The numbers we've already solved for. You get 13.4, a little bit off, right? You're always going to be, not always, but you can be off because of the amount of rounding. You do more rounding in the x and y component method, which is another reason why someone like Restall would prefer the sine and cosine, because it's fewer steps means less rounding and a more accurate number at the end. And I guess if you're designing a building, a decimal place might matter, right? In physics class, it doesn't matter very much. And there's our angle at 24 degrees. So I just did the angle here, inverse tan of y over x, and there's my answer. So it's not exactly the same, okay? But I'm check marking it anyway. It's a good answer. Good work. Okay, let's stop there, and I'll do the next example will be a whole separate video.